Hello, in this video, we're going to take a look at another example of manipulating Taylor series. So we are given a Taylor series, we know. We know that tangent inverse of x is equal to the series k equals 0 to infinity of -1 to the k, x to the 2k plus 1 over 2k plus 1 for the absolute value of x is less than or equal to 1. We want to find the Taylor series for the function x to the fourth, tangent inverse to x cubed, for these and find the interval as well in the process. So what we can do is make this tangent inverse x look like x to the fourth tangent inverse 2x cubed. So the first thing I'm going to do is take that 2x cubed and plug that in. So everywhere I see an x, I'm going to put a 2x cubed. K equals 0 to infinity of -1 to the k, 2k plus 1 over 2k plus 1 for this absolute value is less than or equal to 1. Everywhere I see that x, goes 2x cubed. That x get replaced with 2x cubed. The other thing that's necessary is multiplying by this x to the fourth. So x to the fourth times x to the fourth. So there technically is the Taylor series. Say technically because we actually want to simplify this more. We have the Taylor series, we just want it simplified. So we have x to the fourth tangent inverse to x cubed equals, the first thing I'm going to do is distribute that exponent of the 2k plus 1. It's going to get multiplied by 2. So I have 2 to the 2k plus 1. And I have x cubed to the 2k plus 1. And x cubed to the 2k plus 1, I can take the 3 and multiply by the 2k plus 1 to actually get 6k plus 3. And then the over 2k plus 1 stays the same. And then 4, I'm going to start solving this. I'm going to divide everything by 2. So I have x cubed is less than or equal to 1/2. And then one more simplification, and that's going to be multiplying this x to the fourth in. From our properties of Taylor series or properties of power series videos, we know we can just multiply a power in by adding the exponents. So since a Taylor series is a power series, we can use the same rule. So 6k plus 3 plus 4 is 6k plus 7. Over 2k plus 1, 4. Now, continuing to solve this, I'm going to take the cube root. Say the absolute value of x is less than or equal to 1 over 2 to the 1/3. Last thing this problem asks us to do is to find the first 4 non-zero terms. We have the Taylor series. Finding the first 4 non-zero terms is just plugging in values of k. So when k equals 0, we have -1 to the 0, which is 1. 2 to the 2 times 0 plus 1. And that will be 2 to the first. X to the 6 times 0 plus 7. X to the 7th. Over 2 times 0 plus 1. That is 1. So 2 over 2x to the 7th over 1 is the first term. The next term would be if k equals 1. So if k equals 1, negative 1 to the first is negative 2 to the 2 plus 1 is 2 cubed. X to the 6 plus 7, x to the 10th. And 2k plus 1 with k equals 1 is 3. When k equals 2, we get 2 to the 5th, x to the nineteenth, and actually back here, I read this as a 3k, not a 6k. 6k plus 7 back here would be 13. X to the 19th all over 5. And the last term, when k equals 3, we'd have negative 1 cubed. So that would be minus 2 to the 2 times 3 plus 1. That's 2 to the 7th. X to the 6 times 3, 18, plus 7, be 25, all over 7. So there are the first 4 non-zero terms of that Taylor series. So that polynomial written there, kind of ugly polynomial, but a polynomial nonetheless, would be almost the same as working with x to the 4th tangent inverse 2x cubed.